So, hello everyone. I want to talk today about message-driven architectures, how to build it, and basically message-driven or event-driven architecture, it depends, but in the case it will be message and driven architecture. But let's don't go too deeply to the definitions. We'll go through some practical examples which can help you in real life. And we'll use the Watermill library to build this kind of application. It's a library which I created with my two friends, and I think it may be useful for you. But if you don't want to use Watermill, it's totally fine. I will talk about some common patterns which will work for every programming language, not only for Golang, and for every other library. So, what is a message-driven architecture? So, for the beginning, let's start what kind of problems can solve this kind of architecture. And probably the most popular things are scalability, resiliency, and lower coupling. And I will show how it can help you with some examples. But from the other side, it has some problems. And probably, if you are familiar with more HTTP applications, it can be harder to implement this kind of application for you. It can be harder, yeah? That's probably because if you are starting programming, you are not starting with building some message-driven application. You are basically starting with some REST API or HTTP server. So it can be something new for some of you, and it can maybe harder to debug. And it's because the more distributed nature of this kind of applications. But in my opinion, building this kind of applications can be easier, and it can be probably as easy as building some HTTP application. So probably everyone here can say that building some REST applications is not basically so hard. So I will convince you that it can be really, really simple. And we'll use for this some proven patterns. And as I said before, it's not only Golang patterns, it's not only Watermill patterns. There are just common patterns for every language. And then, as I said, we'll use the Watermill library. So let's start with some company X. So let's imagine that we have some company X which want to build some room bookings portal. You probably may know already some companies which are doing the same business, and you know there is really nice company who have really talented developers. They had really nice business people. They have a lot of money, so they have probably everything to make a big good business. And as I said, this company have some really nice developers, so they decided to talk with business for making this application. So it's probably a good idea. Maybe some of you may know the technique event storming, and I will not talk about this method today, but it's really useful for visualizing the flow. So at the beginning, you can see that, or not see, that at the beginning, some guest may book a room, and after a room is booked, you can initialize payment, and this initialization can be made on some external service. And during this event storming, one of the junior developers asked a really good question. What if this payment provider, which is some remote website, will go die? It may be a problem, but you know, it was some senior developer who said, I already was working with this kind of services, and it will be fine. It was working, so don't be afraid. So they started to code. And you can see here that they created some endpoint which can be used for make a room booking. Yeah, so it's some REST endpoint, and it's a repository, nothing interesting. So you add some booking to this repository, and after booking is done, you can initialize payment in some remote provider. Looking good, yeah? But unfortunately, after some time, after getting some traffic, this payment provider just go down because they can't handle this big amount of traffic. And it was working too slow or basically not working. So it's not a good situation because if this payment provider was down, the many parts of our system was also down. So it's not a good situation for us because our guests don't want to wait 5 minutes to room a book. So we need to fix it in some way. And the question is how to fix it. And after some brainstorming, this team found a really nice idea. And they already read some wise book. And this book say that we can resolve this kind of problems with building some message-driven application. But there was still not pretty happy about this idea because they didn't build such kind of application before. They was building only some synchronous RPC calls and REST APIs, so they are not so sure about using this. But after some thinking, they decided to experiment with this approach, and fortunately, they found Watermill to do this. So this is an architecture that we have now at the beginning. So you can see here that we have some guests here, and guests can book a room, and after booking his room, they can initialize payment at the payment provider. And this is our dream architecture. So our dream architecture is that after booking a room, we will send some event or message to the PubSub or a queue. So it can be some Kafka, RabbitMQ, whatever. And after, we'll initialize this payment at the background. So when this architecture, when the payment provider will down, our application will be still working because it's good for us that this payment can be done, initialized a bit later. So let's go to implementation. And as you can see, it's this handler, HTTP handler, which we used before. And you can see here that we have some still at the bottom that we are adding some bookings. But instead of initializing payment, we are creating some events. So in this case, we have some room booked event, which is pretty simple struct. Yeah? It contains some bookings UID, room ID, price, and payment channel. And we are publishing it using some publisher. So it's probably the most important change here, that we are just publishing some event here, and that's all. The process can end here. And what is this publisher and what is this message? So this publisher is a Watermill publisher, and the first argument for publish method is topic. If you are not using message-driven application, you were not using some event-driven applications before, you may not know a term topic. So topic is something similar to, let's say, database topic. So if you have multiple events, you probably don't want to push it to one topic. You probably want to split it to multiple topics. And in this example, we want to push it to the room bookings topic. And we need also create some message. So message is some pretty easy type, which contains message UID and payload. And you can see here that the payload, the event, is just slice of bytes because we are serializing it by JSON. It can be JSON, it can be protobuf, it can be Avro, whatever. And it's everything from the side of the making a booking. And we'll use for this example a Kafka publisher, but it basically doesn't matter. It's only some default configuration here. It's nothing interesting for you. The important part is that we have already some PubSub implementations in Watermill. So we have Kafka, we have RabbitMQ, we have Google PubSub, and many other crazy PubSubs. But you can eventually, of course, implement your own. So if you have some publisher, you need also subscribers. So the part which will consume these messages that you just published. And it's also some not interesting default configuration. So don't go deep to the details. If you're interested with these details, just go to the documentation of Watermill. And the second part, the last part, which we need to process these messages, is a message router. And message router is also something similar to the HTTP. The only difference is that we will not define an endpoint to which we will be listening. We are just defining a topic from which we will receive the messages, and we are defining a handler. Handler have a pretty similar signature to this from HTTP, but it's a bit different. And also in message router, we have middleware. And middlewares are working exactly the same like in HTTP router. So you can easily write your own middleware. So for example, we have some recover middleware here. And you can see here a handler function signature here. So you will receive a message, and you can produce some slice of message. It's of course optional. Not every handler will return a message, but it's really useful that you can process these messages and just return some messages. And as I can see here, handler middleware is accepting some handler and returning some handler, so you can wrap it really easily. And here is how the handler is looking like. So we moved all this part connected with the payment initialization to this handler. And let's start from the top. So at the top you have handler name, and it doesn't matter at all how it's named, but the more important parameter is room booking. So it's a topic from which we'll be consuming this event. So you can remember that we were publishing messages to this topic. And also we need some subscriber instance, which we created also. And here's body of our handler. And as you can see here, that we are receiving this message. We need to unmarshal this payload of this message to this struct which we created before. And after we unmarshal this, we can make some payment object. And after this, we can initialize the payment. And that's basically all. We already made a message-driven architecture. And after this, it's not a problem for us when this payment provider is done, because when this payment provider is down, the message will be redelivered again. So it's not a problem for us, and it will not stop us making a bookings, because we'll simply do not notice this. And you may ask how it will be handled if this handler will return error in some of these places. So by default, the messaging infrastructure will deliver this message again. But unfortunately, if we are using some backend like Kafka or RabbitMQ, we will be not sure when it will be redelivered. So it's better idea to use some middleware to handle this redelivery. And we can set how many times we want to redeliver this message and how much time we want to wait between these retries. So we have really nice power on this, how to make this retries. We can also set some backup, so we can increase waiting time by count of retries. So as I said, we already solved one problem with this architecture, but unfortunately we have another problem. And another problem is, let's imagine that one of our messages is invalid JSON. It's a problem because it will be redelivered every time, and the message number 4 will be processed forever, yeah? And the message number 5 will be never processed. So how we can handle this case? And it's pretty similar to a bad request HTTP response. But with HTTP response, we have no problem because it will just fail, and that's everything. But in this case, it will be processed forever. So how to fix this issue? And fortunately, it's one pretty simple pattern to do this, and it's poison queue. And the idea is really simple. The idea is to have some separated queue to put these invalid messages to some another queue. It's probably a good idea to monitor this another queue, and if something is sent to this queue, we probably check the messages which were sent. And probably you cannot do it automatically, but because you cannot guess all errors that you can occur. But sometimes you can, for example, fix some logic of your application and just redeliver this message again. But it depends on case. You can, for example, if the JSON is invalid, you probably would find cause of this error and fix this. And you may ask how to implement this poison queue. And it's pretty easy because you can also use middleware for this. In general, middlewares are pretty useful in Watermill because you can make one middleware set for entire router, so every handler will use this, and you don't need to duplicate this logic for every handler. So it's pretty good. You can call also make some configuration for multiple service, so you don't need to remember every time to implement this poison queue. And enabling poison queue is pretty easy. You just need to have some publisher to publish these messages to this poison queue. It can be the same, yeah? But you probably want to specify another topic to send these messages. And as you can see here, we are adding this middleware in Watermill router. And it's also a good idea to sometimes put some retries before this poison queue. So for example, we can retry processing some of the messages a couple of times, and if it fails sometimes, we can just put it at poison queue. But it's another problem with this poison queue. Let's imagine that our database is down. And in case when database is down, we just cannot redeliver this all messages. Sorry, it doesn't make sense to put these messages to poison queue, because if we receive another message, well, it will just also fail until the database is not up. So it's probably a good idea to use some more sophisticated version of poison queue, where you can decide which kind of errors can be sent to the poison queue, because you are receiving in here the error which was returned by handler. So you can decide that only some invalidation error are going to the poison queue, or for example, you can decide that some MySQL, for example, errors will not go to the poison queue, because it doesn't make sense here. And yes, we solved some problems. So business noticed that you are great programmers, so you can implement something new. And it's a small feature. It's just a really simple booking counter on the main page. Easy, yeah? It's just doing a SQL query. Not so easy, unfortunately, because, as I said, we had really good people to build this business, and unfortunately, this business became popular. Well, it happens sometimes. And it's not just doing a query, because let's imagine that we are storing all this booking information between multiple continents in multiple database shards, and basically making this count query will be pretty expensive. So how to manage it easily? So as you can remember, we also are already sending an event when we are booking the room. So probably the best idea will be to add some bookings counter service, which we will also use the same event which we are sending on the room bookings, but it will be just count how many bookings we did. And we'll also use some interesting thing to achieve this, which can simplify a bit in our code. It's a CQRS component. Maybe you know CQRS. If you don't, it may be useful for some part of your projects. But it doesn't matter. You don't ever need to use this CQRS component. You can just still use these handlers. But it's some higher level abstraction, which is totally optional. Also, if you like CQRS and you don't like our CQRS implementation, you can build your own. It's up to you. So how it will look like? So in this CQRS implementation, we need to implement one interface, and this interface is named event handler. So for this event handler, you need two methods. It's one method is new event, and the second one is handle. You probably noticed this empty interface here. Well, probably it will be solved with the generics, but now we don't have better idea for this. But fortunately, we are always sure that we will receive this event and this type here, so we can easily cast here. And this method is required to make some really easy matching of the events which we are receiving. And that's all, yeah? You can see here that we are receiving this room booked event, and we are calling some repository to increment booking counter. And that's all, we already have this feature. And after making this feature, business was really happy, and they went to us again. And they said, we want to have the really nice full text search of our bookings. And it should include some country information, etc., etc. Great. So we decided to add another worker here to build some read models on the Elasticsearch to have really nice search of this. So we can put some extra data for the bookings, for example, some street name, which probably is not in this database, which is here. So we can make something which is named Polyglot persistence. So with this kind of architecture, it's pretty easy to synchronize it pretty well. But we need to remember now about one very important thing, that if you are adding multiple services which are using these events, it's really important to keep backward compatible contract, because if you will, for example, remove some fields from your booking room booked event, it can break some parts of your system which you will probably don't know that they are already exist. So it's probably a good idea to use some, I don't know, protobuf maybe Avro. JSON is probably, okay, it can be good for the beginning, but after some time, it can be a good idea to use some protobuf. So we have already a nice feature set. But unfortunately, with some new feature, we have some new problems. And the problem is that some data is not up to date. So for example, some business stakeholders went to us and said, okay, I did booking 1 minute ago and I cannot search it with our search engine. Why? And the reason is pretty easy. It's an eventual consistency. And you need to remember about this thing in every messaging system. It's not only about Watermill, it's not only about Golang, it's for every messaging system. And what does it mean? So let's remember that we are making the booking here, and after making a booking, we are sending some event here. And these events are not processed here synchronously. So does it mean that it can be some delay here? For example, let's imagine that we have a lot of bookings, and we have one node Elasticsearch with, I don't know, 1 GB of RAM. It probably will be pretty slow. And in this situation, indexing of some bookings information can be delayed. And how we can deal with this? Unfortunately, we cannot. And it's but from my experience, it's not a problem for a big part of application. I can give you an example. For example, probably you are using Facebook, Twitter, or VK here. And sometimes you may notice that some data in some views is not up to date. For example, it's less likes in one place, it's some comments missing, and this is because of this eventual consistency. So these companies probably decided that it's cheaper to just accept this fact that some parts of the system will be not consistent after some time, but basically we can live without this. So, and it's not so often problem. So now we know that we need to live with this eventual consistency, but there are more problems behind us. And for resolve this problem, we need to know some debugging tools which will be helpful for this kind of architecture. And as I said at the beginning, it may be harder because of the distributed nature of this kind of systems. But fortunately, there are also some really useful tools for doing this. And the first tool, let's say tool, because it's not a tool, it's more technical, I think. And it's a correlation ID. And correlation ID is some ID which is generated when some request enters our system. So for example, the place when a request enters our system, it's room booking endpoint. So at the room booking, we want to generate some UID which will be passed for every message and request which will be done in our platform. And we can also use middleware for this. For example, if we receive some message by Watermill, we can save this this UID, correlation ID in some message metadata and just pass it for every message. So we don't need to remember to pass this manually, because we are all humans, yeah, and it's not a big problem to miss to pass some value. So it's a good idea to make it automatically. And how it's looking in practice. So you can see here that it's some log from Elasticsearch, and we are putting some correlation ID here, and we can receive all logs in our system which are connected to this request. So it's pretty useful. And it's probably a good idea for to return this correlation ID in some header in our response, because it's easier to debug it in that way. Another really useful method is making metrics. Sounds pretty obvious, yeah? But we decided to do it pretty easy in Watermill. So you just need to make some really simple configuration to have Prometheus metrics out of the box. So you need to create some exporter, define some ports, do some boilerplate, and it will be just working. Doesn't matter how, it will be just working. And you have also this dashboard out of the box. So you can see here that you have some handler time, percent use, operations count, etc., etc. So it probably can be pretty useful. And as I said, it's totally out of the box. And it's working both for CQRS components, for raw router, etc., etc. And the last thing, which is pretty useful, is tracing. In this moment, tracing is in progress, so I think we'll release this tracing middleware in close time. We'll see when we will have enough time for this, but it will be also just a middleware which will do tracing out of the box for your entire Watermill-based application. And it's how it's looking like in practice. So you can see easily analyze to which system some requests went and how much time it's taken to be executed. So it can be also really useful for debugging. And when we learned how to debug, we can fight with probably the last issue. And it will be probably the nicest one. And it's an issue that sometimes we receive some calls from hotels that some guest comes to our hotel, and we have 2 rooms booked from here, but unfortunately he was booking 1 room. Interesting, yeah? And okay, we found one of this reservation, and we can see, okay, we have booking for this UID, and we have another booking for this UID. Interesting, yeah? And to understand this, we need to go deeper for understanding how messaging infrastructure is working. And there is the perfect word, which doesn't exist, but in most cases it will work like this. So we receive some messages from broker, so it can be Kafka, RabbitMQ, whatever. And after receiving this message, we'll probably save some data to database. And after we save this data to the database, we send acknowledge to the broker, yes, we received this message and we process this. Great. But what if we receive some message from the broker and, for example, our subscriber died because, I don't know, message was pretty invalid and we had panic, something like that. So broker doesn't know that it was processed or not because it was panic, nobody handled this, and well, it blew up. So broker will assume that this message was not produced and it will be sent again after some time. It depends on the broker implementation, of course. But it's pretty good, yeah, because we don't have any data inconsistency here. But what if we receive some message, we save some data to the database or called to some external service, and after this our subscriber died? It's a problem, yeah, because broker doesn't know that we already processed this message, because after sending the acknowledge, our service died. And in this case, the broker will also assume that we didn't process this message, and it will send it again. So we will send some data here again. And it's named at least once delivery. And in sometimes we can configure some infrastructure to have exactly once delivery. So, sorry, at most once delivery. So it's the case when we have this problem, a broker will assume that message was processed and will not send it again. But in this case, this message will be lost. So in Watermill, but by default, we assume this one. So that message will be delivered at least once. So it can be delivered twice or 100 times in theory. And as you can notice in these logs, after making this one booking, we lost connection to Kafka. Oops. But it makes sense, yeah? Because of this, broker didn't know what is going on, and it assumed it's better to redeliver this message again. And it's one solution, pretty simple, to avoid this kind of issues, and it's named deduplication, or idempotency. And it's basically sending in some database the information that we already processed this message. So for example, if we are storing some data in MySQL, it's a good idea to make some, for example, unique key for bookings in this case, and ensure that we already processed this, didn't process this message again. I will show you how we can implement it by using some simple map. So it's some increment bookings counter implementation. So it's from one of the examples. And before incrementing the counter, we are checking in some map that we are processed already this booking. And if we already did, we are just returning without incrementing the counter. And when we didn't process it before, we are adding some information that we already processed it. So it's pretty easy, and it should work pretty the same for every database. It basically doesn't make sense for some memory implementation, but it's good to understand how it can be implemented. And it's basically everything about these mistakes which you can occur during making this kind of applications. I'm pretty sure that with this knowledge, you should feel confident enough to start building this type of applications. And as this team from company X, don't be afraid to experiment, because at the beginning, if you was not building this kind of application, it can be a bit awkward for you because of this at least once delivery with this tracing, etc., etc. But it's not so hard as you may think. And I already covered, I think, a bit part of issues which you might find with your applications. So. I will recommend you to, if you are interested with Watermill, to check the documentation of Watermill. It's a lot of documentation here. So if something is missing, just write to us. We are on the Gopher Slack, for example. Here's the source code, so it's totally open source, and you can do whatever you want with this. And I also created some repository with this code which I used for the example. So it's totally complete project. It have Docker Compose with Kafka. You can just run this and play with it and check how it's made. And it's my Twitter. I sometimes put some nice things for this Twitter. I also share some of my blog posts on this Twitter. So it's everything from me. Thank you.
Thank you very much. Questions?
Hello, Robert. Thanks a lot for your talk. And my question is there any way to provide transaction safety for this kind of architecture? I mean, if one handler fails, then how to revert operations performed by other handlers?
Or can you repeat?
If one handler fails for this message, how to revert operations performed by other handlers? Provide transaction safety.
Which safety, sorry?
Transaction safety. If the message fails in one handler, how to revert operations performed in other handlers?
Can you get here?
And to try to replace, so do you have any consistency for transactions, for example, like in database, where you can roll back your message, for example?
Okay, you are asking about. Okay, probably I know about what you are asking. So, if you are sending something to the database, it's a good idea to save this data in transactions. So, for example, if you are making that application, if something was duplicated, this all data will be rollbacked. So, it's not a problem for you because you will roll back all of the data. It's pretty easy for when you are using some transactional database. It's harder when you are using some non-transactional database or some remote system. So for some remote system, you probably need also to have some acknowledge from some webhooks or something like that. Well, you were asking about this? Okay, thank you.
Hi. Thank you for the presentation. As far as I understand, you had some plans about implementing Saga pattern. Can you explain a little bit how it will look like on a typical application?
So which pattern?
Saga. Say Saga. S-A-G-A.
Saga. Okay. Yes, we are thinking about this, but it's not implemented now. It probably will be in some kind connected to the CQRS. But it's not so close future, I think. But you can easily implement it by just already existing tools, because for the sagas you need also to have some persistence, abstraction, etc., etc. But yeah, we was thinking about this already, so probably after some time. But it will be also some component because it's not the part of, let's say, core domain of Watermill, so it's some separated.
Hello, thank you and sorry for my bad English, but I have questions. What about grouping messages?
Sorry?
Grouping messages.
Grouping
For example,
messages?
I have many messages. After this, I handle it all and process new messages.
I mean grouping messages, yeah?
Grouping.
No, we don't have any tools for this. No.
It's hard, it's not needed.
I didn't thinking about this, so we can talk after, but maybe it can be
Thank
done.
you.
Thank you.
Hello, thank you for your talk. I'm here.
Yeah.
In the left for you.
Here.
Okay, my question is, can I use Watermill library with Kafka exactly one semantic?
No. We can also. You have already pre-implemented RabbitMQ here. We have also Google PubSub, and you can implement your own PubSub if you want. We're also providing some abstract tests, so you can use these tests for testing every PubSub. Because basically, for every PubSub, you want to publish some message and receive this message. There are sometimes some different scenarios, but basically it's the same. But yeah, so Kafka and RabbitMQ and Google PubSub are the, let's say, most popular, but we are also thinking now to implement some MySQL based. So it's good if you are, for example, in some part of transition, for example, and you don't have messaging infrastructure, and MySQL can be enough for you. So it can be just select from the database every second, because for some system it's just enough. But maybe in some future we'll also include maybe some binlog reading messages, so we'll see.
Okay, thank you.
Thank you.
Hello, thanks for the talk. Did you make some research before developing Watermill? Did you compare it to, for example, Event Horizon, which of course it gets much more and it doesn't have message subscribe, no, but probably you can just implement it in that case.
Yeah, I already checked a lot of libraries like this. So I also checked some Java libraries, PHP libraries, and a lot from other languages. I also checked everything from Golang. So in my opinion, it's more idiomatic Golang library, let's say, and it's, I think, easier to extend, and it's more generic, so you can really, it's really highly customizable, for example. So I think that is better, and I think that's the reason why it's better than some other languages implementation, because we also checked some other languages implementation, looked for some lags on this implementation, and also we were talking with some people, and we tried to build something which will be just better. And the idea was to make something which is really easy to use, and it's similar in some way to HTTP. So you have some router, you have some middlewares, and it's really simple to understand. And basically, it's also really similar. And funny fact, we have also HTTP PubSub implementation. So in this case, subscriber is just HTTP endpoint, and the publisher is HTTP webhook. And it also fits the this abstraction. So this is the way how we build this. So it's probably totally different than even for Horizon, I think. Thank you.
Okay, thank you. That was the last question. We have to continue.
Thank you.
You have one present for the best question.
Okay. Thank you.
Thank you. Thank you very much.